So I guess today we've got Thomas who's joined us, so it might be useful just to start with a bit of kind of introduce yourself and what your role is at Argonne.
Yeah, so I'm Thomas Applencourt. I work at Argonne, and I focus on working for Aurora, will be the Argonne exascale system. And so, yes, this is my job to be sure that to test compiler and to give feedback. So Intel will be the provider for the computer. So we work closely with Intel to be sure that we have a good compiler. And one day, Intel arrived and says that in addition to OpenMP, they will support SYCL for Aurora. So we needed to develop some kind of expertise inside the group. And I was the chosen one to be able to to develop a little expertise in SYCL.
Cool. That sounds good. And that's the Aurora machine, isn't it? Yeah.
Yes, exactly. The Aurora machine, yeah.
Cool. And the other thing I was curious about is like, when did you start working with SYCL? Because I guess you talked about Intel said they were going to support this new programming model. When did you start looking at it?
Yeah, exactly. So Intel will support Aurora as a programming model. Will support SYCL as a programming model for Aurora. And I think it was a nice programming model because it was simpler than OpenMP, right? So OpenMP specification is far too long for my little brain. But for SYCL, it's kind of okay right now. It's still manageable. So this is what I like it. I have a feeling I understand more SYCL than OpenMP because, okay, hello world in OpenMP are easy, but if you go deep inside the detail are really, really obscure. So I think it's a good point for OpenMP, for SYCL.
Yeah, that's cool. That's good. And I think you've been doing a bit of training people in SYCL as well, I suppose, internally and externally. How have you been finding that?
Yeah, I think it is nice to teach people. I'm always afraid to teaching people because C++ is also complicated. I'm always afraid to have like super deep template question or whatever. But most of the time, I think it's good. I think people like this kind of how can I say, C++ way of doing parallelization and everything. And I think it went pretty well to have some example. And now that we have a large variety of compilers, this is nice because they can always find some compiler to try on their machine regardless of their architecture. So that helped a lot.
Yeah, no, I think so as well. Yeah. In fact, we've got Axel's on the call as well, who's leading the HipSYCL project. So I think there's a lot of different configurations, a lot of different compilers you can use, which is great.
Yeah.
Cool. Okay. Well, yeah, my name is Rod Burns. I didn't introduce myself. I'm from CodePlay. I work within the team there, trying to help people to learn more about SYCL, to adopt it, and to use the different implementations that are out there. I've been involved in various training sessions for SYCL at different conferences and stuff like that. And really my goal here was just to kind of bring people together, a bit of knowledge share and stuff like that. So before we go into talk with Thomas, we are recording this, so the idea is to cut it down and we can publish the talk on YouTube. I think it probably makes most sense to save questions until then, just to, I guess, for the interest of continuity, especially for recording it as well. But there'll be time at the end, assuming that Thomas is happy to stay for longer to ask questions. So feel free to write them down and ask those at the end.
It's an holiday. I have nothing else to do.
Yeah, yeah, indeed. So without further ado, I'll pass over to Thomas and just check that you can share your screen and stuff like that.
Yes, let me find here, share screen. Oh, sorry. Hop. Can you see my nice
Yep, yeah, I can see
LaTeX? Yeah, as you see, I come from academia, so I don't use PowerPoint. It is
fair enough. Probably for the best.
So thank you very much for assisting my talk about SYCL context. So I will try to address this talk for a lot of people. So I think some of the idea in this talk would be really useful if you are an application developer or a library developer. And I have also maybe at the end of tips, maybe if you're part of the committee or something like that, about language design and something like that. So I will try to to appeal to a broad spectrum of people. And so it will be about unified shared memory and context. And the problem I saw in real applications that people are developing at Argonne, or we are working with other people who are developing SYCL, and I saw those problems a few times, and I think it is important to raise a priority of, or at least educate the people about this kind of undefined behaviors that you can write in your program, and it breaks stuff. So I will just start with an introduction, maybe just recap a few SYCL concepts just to be clear. And after I will go show you some real example I saw in code about the problem of unified shared memory and the undefined behavior you can have. And after some few solutions. So if you do one device, it's pretty trivial. If you do multi-devices, it's more complicated. And for more information, Jeff did a good talk, I think last year, about how to use multiple devices on SYCL. And here I will continue this idea of multiple devices. And then a conclusion and maybe more little discussions that we can have because we're a small committee. Let's get started. So this work is based on SYCL2020. So if you look at the talk later in the day or in a few years, it will maybe everything will change. So please be careful. And it is my interpretation of the specification. So I may be wrong. I may totally be wrong. So take everything I say here with a grain of salt and split, and we can just start discussion and everything. I try my best. I talk to people and everything. So I'm pretty sure I'm safe on the main idea, but maybe in the point of detail, I may be wrong. So sorry about that. So let's start with the basic, right? The naming convention in the SYCL. So I will talk about 4 things here. So a device is just an abstraction of a piece of hardware. This is good for us. A platform is just a collection of devices, and a context, I think this is what I like in the definition. The official definition is just say a context represents a runtime data structure and state to interact with a group of devices. Okay, so I think it is a key point. Is a context is not linked to one device, is really linked to a group of devices. And a queue is something that holds a command group to be executing on the devices. And I think I don't like that much it's the definition because they link queue to only a device, and we'll see later that queue are more bound to a context and a device. But this is just the term we'll use. So we'll use device, platform, context, queue. And to get maybe a better description, and really from the API, I put a little, I took a few hours to write a TIX diagram. And it is a new LM diagram to explain the relationship between all these different components. So how you read that is you say, for example, a device, you go at the bottom, is part of 0 or more queues, right? And the thing is, maybe we can do top to the bottom. It's a device can belong to one platform, right? A device is really bound to one platform. Like we saw a definition, a context is bound to a list of devices. So a context can have one or more devices. And maybe the most important thing here, it's a queue is bound to one device and one context, right? I think it is the main point is a queue is bound to one device and one context, but the context can be bound to multiple devices. And I think this is the translation of the diagram I show in SYCL code. And this is maybe how one can write a SYCL code if you really want to follow the same hierarchy. So you create a platform. So the platform can take another additional if you want to have a platform who contains GPU devices and everything, but it doesn't matter here. So you create a platform. Then from this platform, you ask for all the devices of this platform. So you get back to a vector of devices. Then from all those devices, you can create a context, right? And after, when you create your queue, you take this context and you choose one particular devices of this context. So here I took the first one. And this is really the translation of the concept I showed you before and here. And for now, everything makes sense and it's easy to understand. And then I think during the lifetime of the SYCL specification, it was maybe one disadvantage is SYCL was relatively verbose. So I think we say it would be better if we can just bypass everything, right? In CUDA, you just create a stream. You don't need to care about this hierarchy. So in SYCL2020, I think it introduces this kind of context-free or whatever queue constructor. So a queue constructor without context. And you have two main, you have this one, you can create a queue with a free function. So you create a queue without any argument. And after you can go back this hierarchy, right? You can go top. You can get as devices and this context. So this is nice. And you can also, if you want, creating a queue just bound to one particular devices. So you create a platform, you choose a device, and after you create a queue with these particular devices. And after, if you want, you can get back the context with this member function. I think here, and by experience, I think what it is overlooked is like you always creating or using implicitly a context. It's not because you don't create one that you are not using one. A queue is always associated with a context. I think it is the first message I want people to understand is like, it doesn't matter how you create a queue, it will be always bound and associated with a context. I know this is starting to have the interacting question is, what happens if I create two queues, right? In this example here, I create in line 6, I create two queues who target the same devices, right? So two queues are run on the same devices. And most of the people, or maybe naively, you were thinking they will share the same context, but it is not the case. It is undefined behavior, right? The specification doesn't say about anything about which context this context-free constructor will use, right? So don't rely on that. Don't rely on the fact that it's not because you use two queues which target the same device that you will get a context. Right now it's just for your information, but you will see next slide why it is really important. So I just here said the really different kind of notion, and now I will show you why it is a problem and what it is a real problem and the code I saw that people are using and trigger undefined behavior. And as you know, undefined behavior, when you try to debug, is really, really painful because it works on one architecture, one implementation, it doesn't work on the another one. And you spend hours trying to figure out what it is. So the last notion after I stop promise is like USM, what Unified Shared Memory mean. Some people, I mean, one definition is like USM is when you have a unified address space between the host and the devices. And what here I really use it is more like for the specific API to explicitly allocate memory in SYCL. Right, in SYCL you can use buffers. I have one side of buffer. But you can also use a malloc device, or for example, malloc shared or malloc host. And this is why I will refer when I say USM is really more specifically about this kind of API. So here it is the same example as before, where I create a context using a list of devices. And then I show you the two APIs that you can use to use USM. So one, you can do malloc device. And after you pass which device you want to be associated with, so in which device you want to allocate memory, because it is a malloc device, and after the context. Okay, and because you follow link well, you understand that a device and a context, it is bound to a queue, right? A queue is a one-to-one mapping. It is a bijection between a context and a device. So the smart thing that the API, the SYCL provide is like every time you can use a context and a device, you can also pass a queue because they are exactly similar. And so you create a queue. The good thing is by knowing this kind of trick is like I remember when I learned SYCL, I never knew why I could not do queue.malloc device, for example. It's just because it is not, malloc device is not a kernel you submit. It's really just the queue on the malloc device is really just a syntactic sugar to avoid context and device. And the main trick here is context are used to provide memory isolation, right? This is the main thing about this API is you are passing a context when you allocate memory. And you have this famous sentence in the specification in line in the page 229, who say USM allocation are only guaranteed to be valid in the SYCL context in which they are created. The behavior of access in USM allocation in a different context from it was created is undefined. Attempting to access a kind of USM allocation that is not supported by the device results in undefined behavior. So this sentence is really, really important. And this sentence will really trigger a lot of undefined behavior in code, right? USM allocation are only guaranteed to be valid in the same context. So now let me show you some code that I saw a lot in real life example. So of course, in the trivial code like this is obvious the problem. In the main code is really a pain to figure it out. So the best way is to trace your code using your favorite tracer. For example, you can use Ben intercept layer and you see how many contexts you create. And if you use multiple contexts, you need to be careful. Maybe something phishing is going on. So let's see this example. So I create two queues with their default constructor, right? Then I malloc device two pointer using Q1 and Q2, A and B. And then I do a mem copy using Q1 from B to A. So this code looks easy and it is undefined behavior. This code will or will not work on certain architecture because Q here will issue a mem copy and this mem copy will use B. But B, right, was allocating using Q2. So that means Q1 and Q2 doesn't share the same context, right? Because the specification doesn't require Q1 and Q2 to share the same context when you are using this three constructor. So this code is really undefined behavior. In fact, this code work on certain, if I take the thing I am more knowledgeable about, it's the DPC++, the Intel implementation. If you use the level 0 backend, this code will work, no problem. If you may work if you're lucky and Q1 and Q2 will target the same device. And if you use the OpenCL backend, it will not work. It will give you a runtime error explaining you that Q1 tried to access a memory was allocated in not the same context. And this one happened a lot of time in really complicated code because people rely on this creation of queue and then try to access. I have another example, maybe a little more subtle, or another example just to nail the problem. Here I do the same thing, is just because that's smart, I know I may have a problem, right? I create a queue, I don't know in which device, I will create a queue with a particular devices. So I create Q1 and Q2 with a particular devices, they share the same devices. So I should be good, but I am not. Like I explained to you, it doesn't matter if I create the same devices. Really, memory protection and undefined behavior are really bound to context. Context is the importance notion. It's not devices. Devices is really not that important. It's really about context, everything about context. And in all this example, I put memcopy because it's shorter to write and it fits on a slide, but it's not related. I mean, it's not limited to memcopy. Parallel 4 have the same issue. I use Q1 and I do the manual memcopy and I have the same problem. This code may or may not work. It is undefined behavior. So this is really the big problem. So in summary, this is, I think, the main, if you need to remember one thing of this slide is USM allocation are only guaranteed to be valid in the SYCL context in which they are created, right? It is the main idea of this talk. And now I'm not that horrible. I will try to give you some solution how to do it. For some solution are maybe trivial. Some of them are maybe a little more complicated. So the solution. The easy solution, and I think it may cover a for now, a last variety of usage, because when I see people code, they are really targeting one devices. So if you look at Jeff talk, you use one MPI rank in HPC, one API rank per device. And after each MPI rank will access only one device. So this is what I call the one device. It doesn't mean that your node have only one device. It means that your MPI rank, your process will target only one device. In this case, as you figure it out, as I showed before, the solution is trivial. You just create a context with your device. So same as before, you create your platform. From this platform, you take your favorite devices. I don't know, you have some heuristic to do some spread, not spread, whatever. So you choose one device in here. I took the front. You create a context. And after, you are reusing this context to create the queues. Right, so you just have the one keystroke to add it to your Q1 and Q2, and then you're good, no problem. This code is totally working, is a defined behavior, it will behave as you expect. So this is good, and also the good thing is all SYCL implementation support this code, right? I'm sure and certain that everybody supports that. So if you do this thinking, you are portable, no more solution. How you store your context is whatever you do, a singleton, you put it in some member function, whatever. Or you can also reuse only one queue, but you may lose some for performance reason. You may want to have multiple queues. So the summary, the second summary about this slide, as usual, context, USM abound to context, and the only thing if you target only one device is to reuse the context for all your queue creation. And targeting the same device is not enough, right? I think I told it enough time is really need to do the context. And by experience, I think all the applications are okay using only one context, right? So you can create a one context. The good thing is HPC, we already have this MPI init. So when you have your MPI init, you create your context and that's it. And after you put the COM word of MPI and the context of SYCL in the same data structure and you pass it everywhere and you're good to go. So this one was more for the library developer and now maybe more for the compiler developer and the SYCL committee. And this topic is more an active area of research, is what happened when you have multiple devices, what happened when you want to target multi-devices. And this is where things get maybe more interesting for some people in the audience. So naively, the thing you should do is exactly as before. You create a platform, and only the difference is before, when I creating the context, I was choosing only one device on this platform. And here I will create the context with all the devices on my platform. So you see in line 8, I use DS, and DS is the vector of devices. And then I will create two queues. One queue will use the first device, and the second queue will use the last devices, right? DS front and DS back, so the first and the last. And then I will malloc using Q1 and Q2. And then I will do a memcopy from B to A. This code is totally valid by the spec. No undefined behavior here. The only thing I need to do, so it's nice, the only change I need to do is when I create my context, I put all the devices inside this context, and now everything is fine. So the question is, does the implementation support multi-device context, right? So I did a quick survey. So I was not able to run everything. So sometimes I just look at the source code and everything. So please take this tape with a grain of salt. When I'm sure it's for the DPC++. And for the other, I'm not sure. So I know we may have some developer of those compiler here. So we can discuss after it is true or not. So for DPC++, OpenCL and level 0, you have no problem. You can use this multi-device context. So it's by multi-device context, I mean, when you create a context, you pass a vector of devices, right? In CUDA, for now, it's not the case. It's not possible. It's not implemented yet. We open an issue and we are working actively with CodePlay to be able to implement this kind of feature. I think SYCL reading quickly on the source code, it look okay. 3SYCL, I look quickly, no, and compute CPP I was not able to access, so we can discuss later. So that means this code is portable, but maybe not all the implementation already implement this multi-device support context. Sadly, this is not the end out of the story. So you have another problem is you have this famous table 99 in the specification. And I hope you enjoy the table. It took me a few hours to rewriting in LaTeX, but it looked pretty nice. And it gives you the USM characteristic of the allocation. So it gives you, if I do, for example, malloc device, how this data will be accessible and where this data can migrate to. So let's focus on this one because after you can read it later. So I do a malloc device, and does this data is accessible by the host? No. Does this data is accessible by the devices? Yes, of course. And the funny part is, does this data is accessible by another devices? And here they say optional. So two things to note here, I think two really important things to note here. When the specification say accessible by another devices, what you should read in your mind is really accessible by another devices belonging to the same context, right? Because it is USM, everything is bound to a context. So the question in SYCL to know if you can access the memory of another device who is not in the same context is absurd. It is undefined behavior, we already know that. So here it is really inside the same context. And you see optional in some cases, so it is optional. So that means the code I show you may or may not work because the fact to access memory from another device is optional. So the big question now, like if you are a library developer, you're like, okay, it's optional, I don't care, but I need to know if it is if it is possible or not, right? I need to have some introspection capabilities to be able to check for this optional or not. So this is the bad news, is like as today, SYCL doesn't provide this kind of API. So you cannot in SYCL right now check for this kind of behavior. So can a device allocation on one device can be accessed by another device on the same context. You cannot check for that. So the good news is discussion and proposal are ongoing. How to fix this issue? I will show you two proposals maybe, how we can fix that. If you are as a purely, empirical physicist approach, you can always try. You can create your own API, you put a try catch and you see if you have a good result. And if it is good, you're good. And if it is not, too bad. And at the end, you can always use bounds buffer if you want to be portable. I will show you that later. So the two API, I think, possible, and I think was already discussed, at least the first one is the trivial is like the SYCL specification provide a free function, we'll be able to check a pair of devices. So for a pair of devices, you are like, okay, is shared device allocation accessible by another devices? You press a pair of device and it say true or false. And you do that for all the combination of devices in your platform, in your context, and you know if it is possible or not. Why not? And I got this crazy idea, maybe we can expand the concept of partition that we have for devices, right? You can partition your device with some criterion, for example, NUMA, and maybe we can partition or platform with some criterion. So we say, I want to have a partition of my platform where all the devices in this partition have peer-to-peer access, for example. It's a crazy idea, but I think this is pretty elegant because you are reusing a concept that it is already in SYCL somewhere for devices and you just extend it to platform, but it is more for fun. And if not, you can always use a bounds buffer, right? This is the traditional thing if you want to do it. So here the same as before, right? I create two queues. It doesn't matter if they are in the same context or not in the same context. I just create two queues who target any devices. They don't even need to be on the same platform. And I just create a host buffer with a bounds buffer. and I will use it as a temporary buffer, right? I copy Q2 from D2 to H, and after I copy H from D1. So it's maybe not the most efficient. I think it's always not the most efficient, but it's work. It is totally portable. So this is if right now you want to write a SYCL code with portable in all the SYCL implementation and who is targeting multiple devices, this is your best bet to be portable, just portable. If you want to be performant, you can do other things, but to be portable, this is the thing. So as a conclusion, a full conclusion, so USM allocation, one more time, they are valid, are only guaranteed to be valid in the context they are created. If you don't do that, it is undefined behavior. The horrible thing about undefined behavior is that it may work, right? It is just undefined behavior. So in some application, in some implementation, it will work, and one day you will change system, it will break. So please don't rely on this feature. So that means to be able to access memory, we are not allocated on the same context. The solution is just to create one context, and after just reusing for all your queues. It's pretty trivial. It's still an active domain of development research for when you are targeting multiple devices. Some SYCL implementation doesn't support this multiple devices context. So please talk to them, raise a priority if it is important to you. SYCL2020 is lacking any introspection of this USM characteristic, but should be fixed soon. And I think also you have some discussion in the SYCL committee to be able to maybe introduce a default context notion. So when you create, this, like I show you, when you target, for example, the same devices, maybe it will give you the same context. It is also a possible extension of the specification. Or you can just ban this context-free queue constructor, so no more problem because nobody will be able to shoot in the foot anymore. But maybe it's too a greedy solution. And maybe the last slide to finish, because I really like buffer. I think we should use more buffer. Buffer are nice. Buffer has the future. If you use buffer, you have no problem. Absolutely no problem. You can use buffer between multiple devices. Maybe good implementation will use peer-to-peer if it is possible, or any crazy interconnect networks that you have. So in this case, I create two queues. I don't know where they are. They are just two queues, maybe on different devices. And then I create a buffer of a buffer. And after this buffer will be used in Q1, and after this buffer will be used in Q2. And it works, right? It is spec compliant, defined behavior, everything is fine. So you can always use buffer and all your problem will goes away. And I think it lasts half an hour. So thank you very much. And now we can take any question or anything you want. Thank you very much.
Thanks, Thomas. Really appreciate the talk. I realize we can't really clap, so instead I think Zoom gives you reaction emojis that we can all do to give you a clap.
Don't do the poop emoji, please. I would be really vexed.
There we go, plenty of claps coming through. Yeah, thanks, Thomas, that was great. Does anybody have any questions to kick things off? Feel free to, I guess, maybe if we can try just unmuting and talking, and hopefully people won't talk over each other.
Hi, Thomas. Because the context is still, I don't work with context because I focus on a single device. So I would like to summarize kind of what you said about data transfer between two devices. So I think the idea is that first I need to create two queues, and each queue corresponds to a device. And then if I want to transfer data between the two devices, then I think I can have three ways. The first one is first copy data from a device to a host memory, and then from the host memory to to another device. The second way is that I can use the SYCL buffers to do the data transfer between the two devices. And the last one is, I think is as you said, to pass a vector of devices to the context. And then I can use the USM style memory copy to copy data between two devices. Is that right?
Exactly. Maybe just so everything you say about data transfer is correct. The only thing you say, like you don't care about context, you need to be careful, because if you create multiple queues and at some point in one queue you try to access memory whereas allocating another queue, this is undefined behavior, even if you target only one device. So you should be careful with that. If you're on only one queues and one device, not a problem. If you start having multiple queues, you may eat some undefined behavior. So this is the only conva.
Okay, so the definition of context is actually is associated with a queue. So each queue has its own context.
So
right,
yeah.
Even if the both queues are associated with the same device.
Yeah, exactly. In this code example here, this is exactly you say you have two queues who are bound to the same devices, but they share a different context. If you use this constructor, yes.
I see. Okay. Yeah. Can you go to? Sorry, I don't. It's not a question because I would like. I'm not sure which slide shows that you can pass a vector of devices to the context. I think the last slide is.
So this one, for example, here I have a vector of devices that I got from my platform, and I pass it to the context, and it took the vector.
I see. And you also have another slide that also shows the not only this, but also the memory copy, USM memory copy, right?
Yes, here.
Oh, I see. Okay.
Yeah, here you create with this vector of device, you create a context, and after you can create your queue with targeting any devices of this context. So for your example, this one will be the first, and this one will be the second. The important thing is like they share, you pass the same context in both of the queue. Q1 and Q2 are using the same context.
I see. Yeah, and then you can do the data transfer between two devices, right? Two devices.
Exactly. Yeah.
Yeah, thanks. Yeah, I will put down what your codes, and it's good to learn these context differences.
Glad it helped.
I had a couple of questions. So there was one example where you showed using that bounce buffer, which uses accessors and buffers and accessors. So you talked about performance. Is there quite is the performance difference significant enough that you just wouldn't use this in a production environment piece of software? Or?
So I think this is what I hear. I say here, it's like, in theory, the runtime should be able to figure this thing out, right? Because you give the accessor here, it can understand that it is running on one devices, here that it is running on the other devices. But it can do some introspection and see that the two devices are in the same, connected by peer-to-peer, and just do the correct.
Right, okay.
I didn't yet benchmark this kind of thing because I don't have access anything to any multiple devices who are connected to. I mean, the only devices who is connected by some super fast interconnects that I have access to are NVIDIA with NVLink, and right now I didn't have any time to test it. So I will try with the CUDA backend of DPC++ and see if they are doing some fast memory transfer between the two. But in theory, at least my understanding, it is possible to do that, but I'm not
Yeah.
a compiler implementer or runtime
Yeah,
guy.
sure. So yeah, feasibly the compiler implementation could try and do some magic to help with that. Yeah. Okay.
Exactly.
And I suppose I probably know the answers to this, but why would someone choose to use unified shared memory over buffers and accessors?
Oh yes, this one is a big question. I think if you start from your code from scratch, maybe buffer and accessor are a good thing because you have full control. But if you start porting from another code, is far easier to transfer using USM, right? Because it match easily like CUDA or any other programming model. So I think for people who port, it's far easier to use USM. And also, I think people are afraid of buffers. They are doing a lot of magic stuff, and it is a higher level of abstraction. So I think it is the job of the implementer to be sure that to reassure people that the implementation of buffer are pretty good, and it is really more a zero cost abstraction or whatever, or at least you can pay this price of the higher abstraction, and it will not hurt your performance. And I think it is true. I think it is true. You just need to do maybe more communication benchmark and to be sure that, yes, to teach people that buffer are good.
Yeah, that makes sense. That makes sense. Yeah, I mean, I suppose the whole point of unified shared memory is it provides that pointer implementation, whereas I don't know, I'm not completely aware of any other kind of environment where you'd use something similar to accessors, buffers and accessors, but I don't know. I don't have that much experience in HPC programming, so maybe there is.
No, I don't. I mean, I don't think
it seems quite unique.
Yeah, and I really like that because it give you give a lot of the information of the runtime, and it should be able to do good things with the information you give. So, and for example, for USM, it is a good example where using buffer, you don't care about this kind of thing. At least it is my interpretation. Somewhere in the spec, they say that buffer can be accessible regardless of the platform even. So this is even stronger than thing.
Yeah. I think I've seen quotes from national labs saying they're porting, I can't remember if it was millions of lines of code or tens of thousands of lines of code from other areas. So I could understand why they wouldn't necessarily want to convert it all to buffers and accessors, but okay, cool, thanks. Does anybody else have any questions that they would like to raise?
Maybe I can. Hey, Thomas, I had a question. Thanks for the talk. It's really interesting. The comment about the default context, I think, is interesting. I was wondering if you could share a few thoughts about the default context. In some ways, it seems like that's defeating the context isolation. Maybe my provocative question is: are contexts just a mistake, and should they be deprioritized? Does a default context kind of hide them a bit more? What is your thought about a default context?
Yeah, so this context, this memory protection over context come from OpenCL. So I was thinking you can explain us why contexts are important. You are the essentially. But I think in HPC, really, my experience is everybody is using only one context, right? So I was thinking that maybe other domain, I don't know, maybe embedded or something like that, may need for security reason multiple contexts, right? But maybe it's a security feature. I'm still not sure why this context. I didn't think that much about it. So at least for HPC, indeed, one context should be enough. And I think default context can make sense here, for example, right? You create devices, and after from these devices, you hope, it will solve a lot of undefined behavior if the context creating for these two are the same. Because if they are the same, all the code I show you will be totally correct, right? Because they will share the same context, so the memory allocation will be good. Now the question is, I guess, how it can work is like you create for one device, you get the platform, you create a default context for all the device inside this platform. But now you have all this question about like memory, peer-to-peer and stuff like that. But in HPC, I think all the node will share the common characteristic. For example, all the GPUs inside our node will be connected via peer-to-peer, for example. So I think for HPC, it's a sound default that if you create a queue with only passing a device, it will create a default context for all the devices on this platform. And now each time you will create a new queue on the same device of this platform, you will get back the same context. And this will solve, at least I think, I don't know, a good chunk of potential behavior. So for the queue where you create a device, I think it's pretty safe. I think it's easy to do. But you have the problem where I put that, where you create queue without here. This one is more tricky, right? Because this queue can target devices into different platforms, so you cannot really ensure that you will have the same shared context, right? So I think this one is more tricky. So after you can say, okay, if two queue target the same device, they will share this, but it makes the spec more complicated, and I'm never a big fan of complicating the specification for that. I hope it helped a little bit.
Yeah, that definitely helped. Thanks again.
Maybe I can also add some perspective. So the thing about context that they provide memory separation for some security, I don't think that's really the case. They may do that, but they may also not do that. For example, you could have a SYCL backend that doesn't support this at all. If you're implementing SYCL on top of, say, OpenMP for CPUs, then you can construct all the context you want. You won't get any real new virtual memory address space or something like that. So it's really just more of a thing that came from OpenCL, and SYCL was constructed around it. But I would say it's unclear how it's supposed to fit into a SYCL world where we have a more generic landscape of backends. And I think we should really look at what we want context to be, or even if it makes sense in the general sense. Maybe it could also be the case that it might make more sense that context could just be like an optimization hint for the backend or something, how to group devices together. But yeah, it's a very open question. I agree with your assessment that something like default context for platform could be very interesting, not only for correctness considerations, but also for performance, because I think a big problem is also that the default constructor of queue creates a new context which can have a massive performance impact also. So if you do this by accident, then you may have also a real big performance bug in your code, which is not apparent at all.
Yeah, I think it's a good point, because I heard some talk where people say, oh, queue constructor are expensive. And I think it's not really true. Like you say, it's really more, if you create queue like this, you need to create a context, and contexts are really expensive. At least this is the case in the level 0 backend. So creating queue, if you're already passing the context, are maybe not the most, they are not no-op, but they are far less expensive than creating queue with a context.
Yeah.
And it is a fair point that if you have a default context, now this performance hit, it really goes away.
Yeah. I think there was even a talk at one API developer summit, I think, where a code was presented and the scaling was presented of the code with different SYCL implementations. And it turned out that HipSYCL scaled far better than DPC++ and Compute CPP. And the reason it turned out, when I looked into this code, is that this particular application creates a lot of queue. And in HipSYCL uses implicit context management. So even if you use the default constructor, it's going to be cheap because no new context is going to be created. So performance is going to be much better. While if you try to scale such code with DPC++ or Compute CPP, and you actually need to construct a context, performance will be very bad. So this is actually something that happens in real world code already. And so I think this is something that we need to take a close look at.
Thank you. Yeah. Yeah, and all these bugs are really happening in real code, right? Because of this context, people are not aware of that. And after we did the switch for the OpenCL to the level 0 backend, and for example, some code break, or more the opposite, because OpenCL is really restrictive about this context, where level 0 is more flexible. So it's already have some huge impact in codes. Yeah.
I just have a question about the codes that you mentioned. Which codes? Which codes that show huge impact on DPCPP and compute CPP performance?
It was the locality sensitive hashing, I think, the talk on this.
Oh, I see. Okay. Is there open source code project?
I think I found it on GitHub somewhere, but I don't know the link by heart. I will try to find it and then post in the chat if I find it.
Oh, okay, I see. Yes, okay. Is it from Germany, right? The researchers from Germany.
Yeah, Stuttgart.
I don't think it's. I think I asked him, and it's probably not open source.
So I think also a problem that we need to tackle is this table and get some introspection, because it doesn't matter. Maybe we solve this context issue. We still have the problem. Is this possible to do peer-to-peer, and can you access other devices and everything? So I think to give some introspection are also a valid problem. But this one is just an API missing. So I think it's less a conceptual problem. It's just how to design a good API, but it's less a conceptual issue. Yeah.
Is this something that you're involved in helping to define within the SYCL group?
I should. I should. It's just I didn't have enough time. I think now I was able to free a little more of my time, so I hope I will have more time to access and to participate in the group. Yeah.
Cool. Sounds good. Okay.
So thank you very much.
Yeah, thank you, Thomas. Really appreciate that. That was really interesting. Oh, I think Axel's posted a link to the code there. Cool. Thanks. All right. So thanks again to Thomas. That was great. Tomorrow we have another talk, same time. It's on Zoom. There's a new link that hopefully you will have received via email either already, or there's an email going out this evening to share that with you. It's from Tomlin. He's actually on the line, I think, from University of Bristol, and he's going to talk about the work that he's been doing with this real-time 3D fluid simulation, and how he's been doing research on SYCL productivity. So talking a bit about how he developed that and how that relates to, I suppose, developer productivity using SYCL. So that's going to be good. So please join us for that tomorrow. And if I can move on. The other thing that I wanted to mention, which Thomas and others might be interested in, given the code samples and stuff that he presented today. So we've done a bit of work over the summer with some of the members of our team and some of the members of the team at Intel as well. You've probably heard of CPP reference. So we've been working on a SYCL version of CPP reference, kind of. The idea behind that is to go, I suppose, a bit beyond the specification in terms of helping people to see bits of code in the context of how they might be used, with better explanations of how you might use them. There's been quite a few contributions to that over the summer, and we'd like to keep doing that. And CodePlay is certainly going to keep contributing to that, and I think Robert from Intel's going to be doing that. So I'm hoping that others can get involved. Maybe there's some of your context stuff that could be added to that, Thomas, and maybe others can help with little bits and pieces. So this is the GitHub repo. I think if you search for SYCL reference, it should come up pretty near the top. It's hosted within the Kronos GitHub organization. So everyone should have access to that. But yeah, take a look, tell us, or tell me, tell anyone if you find it useful, and if you can contribute, that'd be great as well. But hopefully we can keep building that up, and yeah, make it into a resource that everyone can go and use. Cool. And I suppose let's leave it there. Thanks for joining us. Thanks again to Thomas, especially public holiday and everything else. And yeah, hopefully we'll see and hear from some of you tomorrow. Have a good day and evening, depending on where you are.